So let's look at the solution for bounded buffer. Okay, here in this solution, the following variables reside in a region of memory shared by the producer and the consumer processes. This is the constant, represent the buffer size. We suppose that it is 10. And we have a type. This type represents an item that placed into the shared memory buffer. And this is the buffer size, the buffer, okay, to shared buffer. And it is a pointer to point the position that the producer put, that refers to the location the producer can put the item in the buffer. And the odd that refers to the location the consumer can fetch the item from the buffer. The shared buffer, this one, is implemented as a circular array with two logical pointers in and out. The variable in points to the next free position in the buffer for the producer to put item, and odd points to the first full position in the buffer for the consumer to use the item. The buffer is empty when in equals to out. The buffer is full when in plus 1 equals to out. Okay, this one. So this code is for producer precise. You can see here. And the local variable next produced. Local variable next produced, in which the new item to be produced is stored. So first you can see this. When this isn't satisfied, when this condition doesn't satisfy, we say the precise will do nothing. Just check and check again till it consumes all the time slice that are allocated to the producer precise. So when this condition doesn't satisfy, that means there is if the condition doesn't satisfy, that means there is a position for producer to put an item. So we can see the program will continue to this sentence and put the new item produced by the producer into the buffer and move the pointer to the next location for refers to the new empty position. Okay, so this is producer precise, and this is consumer precise. Also, there is a local variable next consumed to store the item that get from the buffer. Okay, also the condition is that if in equals to out, that means the buffer is empty, nothing in the buffer. So the while condition, the precise will do nothing. Just check this condition again and again to consume all the time slice that are allocated to this precise. And only when in doesn't equal to out, that means there is at least an item can be consumed by the consumer. So the consumer will get one item from the buffer and move the out pointer to the next position, to the next full position. So you can see this scheme allows at most buffer size minus one item in the buffer at the same time. Okay.